চিকিৎসক মৃত শেখ আজগার আলী উত্তরপ্রদেশের বাসিন্দা অগ্নি নামে থাকা রেজিস্ট্রেশন নাম্বার ব্যবহার করে প্যাট বানিয়ে চিকিৎসা করতেন ওই ব্যক্তি। ডেটিং সাইটে লেকটাউনে মেডিকেল ছাত্রীর ছবি পোস্টের অভিযোগ, নানিয়ার থেকে গ্রেপ্তার অভিযুক্ত যুবক। 5 দিনের ট্রানজিট রিমান্ডে তাকে লেকটাউন থানায় নিয়ে আসা হয়। পশ্চিমবঙ্গে ভারী বৃষ্টি, দিনভর কয়েক ঘন্টার মাঝারি বৃষ্টির পূর্বাভাস কলকাতায়। উত্তরবঙ্গের পার্বত্য জেলাগুলিতেও ভারী বৃষ্টি হতে পারে। আগামী সপ্তাহে আরও একটি নিম্নচাপ তৈরির সম্ভাবনা। উত্তাল সমুদ্র, দীঘার কাছে দুর্ঘটনা ঘটল ট্রলার। ট্রলারে 6 জন মৎস্যজীবী সবাইকে উদ্ধার করা গেলেও তাদের মধ্যে 4 জনের অবস্থা আশঙ্কাজনক। নিম্নচাপ ও ঘূর্ণাবর্তের জোড়া পড়ার জের দক্ষিণ 24 জুড়ে দফায় দফায় বৃষ্টি। সুন্দরবন উপকূলবর্তী সাগর, নামখানা, কাকদ্বীপ, পাথরঘাটা, রায়দিঘি, ফুলতলী, গোসাবাতে ভারী বৃষ্টি। অমাবস্যা কোটালের জেরে নদী ও সমুদ্রের জোয়ারের জল ইতিমধ্যেই শুরু করেছে। বাসিন্দারা বাড়ি ছাড়তে শুরু করেছে। দার্জিলিংয়ের কালিম্পংয়ে 10 নম্বর জাতীয় সড়কে ধস নেমে বিপত্তি। প্রবল বৃষ্টিতে 29 মাইলের কাছে রাস্তায় ধস নেমেছে। কালিম্পং থেকে শিলিগুড়ি ও সিকিমমুখী রাস্তা আপাতত বন্ধ। উত্তরাখণ্ডের বিস্তীর্ণ এলাকায় প্রবল বৃষ্টি। জাফর নদীর ওপর একটি ব্রিজ ভেঙে পড়ায় দেহরাদূন ঋষিকেশের সড়ক যোগাযোগ বিপর্যস্ত। বিকল্পরূপে চলছে যাতায়াত। কাবুলে পাকিস্তান বিরোধী মিছিলে গুলি চালালো তালিবান। আফগান প্রেসিডেন্ট জাকির নায়েক তালিবান বিরোধী মিছিল হয় আফগানিস্তানের বিভিন্ন প্রদেশে। গজনি, মাজারে শরীফে তালিবানের বিরুদ্ধে রাস্তায় নেমেছেন আফগানরা। পাকিস্তানের দূতাবাসের বাইরেও বিক্ষোভ দেখান অনেকে। দেশে করোনায় দৈনিক মৃত্যুর সংখ্যা বাড়লেও কমল আক্রান্তের সংখ্যা। গত 24 ঘন্টায় ভারতে করোনায় মৃত্যু হয়েছে 290 জনের। একদিনে আক্রান্ত হয়েছেন 31,222 জন। অ্যাক্টিভ কেস 3,99,864। এই মুহূর্তে যে খবরের দিকে নজর রাখুন। কাবুলে পাকিস্তান বিরোধী মিছিলে গুলি চালালো তালিবান। মিছিলে ছিলেন 70 জন মহিলা। ওই ঘটনায় কতজন হতাহত হয়েছেন তা এখনো স্পষ্ট নয়। শুধু কাবুল নয়, তালিবান বিরোধী মিছিল হয়েছে আফগানিস্তানের বিভিন্ন প্রদেশে। গজনি, মাজারে শরীফে তালিবানের বিরুদ্ধে রাস্তায় নেমেছেন আফগানরা। তালিবানকে মদতের কারণে কাবুলে পাকিস্তানের দূতাবাসের বাইরেও বিক্ষোভ দেখা যাচ্ছে। তাইওয়ান প্রস্তুতের দাবি তালিবানের বিরুদ্ধে জনমত সংগঠিত হতে শুরু করেছে বলে সূত্রের খবর।
Okay, so we will study now the welfare maximizing capital stock, or the golden rule level of capital stock. Okay, so from this equation, two equation I will write down. First of all, we know at the steady state S into f of KSS. So after solving this steady state, we already got this, which itself a function of small s equals to, suppose I have the standard one with no technology growth, n plus delta KSS, which is the function of s. This is, we know from the steady state equation, and we also know that at the steady state per capita consumption at the steady state, CSS equals to, in the bracket, 1 minus s of FKSS. This is something we already know. So our objective over here is to find out that capital stock, that steady state value of capital stock that maximizes this steady state value of per capita consumption. Okay, so if I simplify this expression, these expressions boil down to so now in the place of s f of KSS, I can write this remain unchanged minus this Fine. This is coming from the steady state equation. Then I'm going to choose S to maximize this steady state per capita capital stock. That is going to give me uh, a small s, and correspondingly I can solve my KSSG. So this is basically what I'm going to do. I'm going to choose a savings rate that is going to maximize CSS, or per capita capital stock, at the steady state. Sorry. So what I get, A prime minus n plus delta within the bracket that has to be equals to 0. That's the first order condition. And if I simply solve this first order condition, that's going to give me a expression F prime KSS equals to n plus delta. If I solve this equation, that's going to give me a savings rate S that is going to maximize my per capita consumption. And once I know that savings rate, I can calculate the corresponding. So after solving this equation, what I actually get, this equation is gives me, after solving this equation, I get an SG uh, savings rate, which I'm denoting it as SG, that maximizes the per capita capital stock at steady state. Once I get my SG, I can just simply substitute this value over here. I know that from that equation, I know KSS SG difficult, so I have to just write it down again. So steady state capital stock corresponding to this savings rate is equals to this G divided by n plus delta, and which is basically I am denoting it by kg, the golden rule level of capital stock that maximizes my steady state per capita consumption. This is basically the stuff altogether. So what is the objective? Objective is basically to finding out a golden rule level of per capita capital stock that maximizes my per capita consumption at the steady state. So what I did, I have chosen a savings rate, small s, that maximizes my per capita consumption. Then I substituted that savings rate to the steady state equation that gives me the steady state per capita consumption that maximizes my uh, per capita consumption. So this is basically it, and I'll do it mathematically, and that will be much more clear after that. Graphically, it basically looks like this. This is how it looks like graphically. This is how it looks like graphically. So again, I'm measuring, let's say, per capita capital stock over here in the x-axis. Y-axis, I'm measuring output. This is my production function, concave. This is my savings schedule over here, S into F of K. I know my steady state capital stock is basically where my savings is exactly equals to the investment over here. This is the steady state capital stock, where the savings schedule is intersecting n plus delta multiplied by k schedule. This one. This is something we have already seen. And this is basically my golden rule level of capital stock, where this marginal productivity of capital corresponding to marginal productivity of capital has to be equals to n plus delta. So I have drawn a particular tangent in the production function which is parallel to my n plus delta line. That's going to give me a corresponding capital stock, kg, and this is the capital stock that maximizes my per capita consumption. So you see over here that in the solo model, the steady state level of capital stock may not be equal to the golden rule level of capital stock. So the steady state level of capital stock may not be the welfare maximizing capital stock. This is basically the major problem of the solo model that we will discuss more later. So you see, this is basically the thing. This is my steady state capital stock. This is my golden rule level of capital stock. Where do I get it from? My golden rule level of capital stock that maximizing my consumption happens when f prime k equals to n plus delta. That is my first order condition we have already derived. F prime k, that's marginal productivity, which is the tangent of this production function. So I have drawn a tangent of the production function at a particular point where the tangent is parallel to n plus delta. That's going to give me a capital stock over here. That's my kg. That's my capital stock at the steady state that maximizes my per capita consumption at the steady state. But steady state capital stock is this, so they are actually different. So here the government intervention is necessary to bring a capital stock closer to KSSG that maximizes consumption. In this case, you see there's a over savings, over accumulation of capital stock. So it's better if you reduce your capital stock by reducing savings, you will come more closer over here and your consumption is going to increase. So if you see over here, there's another figure I have drawn over here. This is basically how it looks like. So there is a golden rule level of capital stock over here where that maximizes my consumption. So that's the two area over here, area A and area B. If my steady state capital stock is at the area B, so that is the over accumulation of capital stock. What is the implication? You reduce your savings so that your capital stock gets reduced and your consumption will be maximized. So over here, you have to increase your savings. Okay, so this is basically the thing. I will come more in detail about this figure, but let me just give you an example about our solution, what actually I meant to say over there. If you can remember, when we have our standard Cobb-Douglas production function, what we actually got is this, right? My steady state capital stock, when we have only population growth, my per capita capital stock at the steady state, this is what we got. When my production function is Cobb-Douglas, I got KSS, which is a function of S, equals to S divided by N plus delta whole to the power when something in the denominator, something in the numerator, 1 over 1 minus alpha. This is my steady state capital stock for a given S. So if I know the value of S, I can calculate the steady state level of capital stock. The question that props up, what is the optimum S? Can government guide that how much fraction of income is going to save? The guide is you save that fraction of income that maximizes your steady state consumption. Okay, so if my production, if it is, let's say, this is basically a condition, f prime kss equals to n plus delta. Okay, so I know from my Cobb-Douglas production function, f prime kss is alpha into kss to the power alpha minus 1. That's my marginal productivity of capital, and that equals to n plus delta. Fine. This is going to give me a value of KSS. What is the value of KSS? It will be going to give me this is going to give me a value of steady state per capita capital stock that's going to maximize my per capita consumption. So KSSG KSSG, the golden rule level of capital stock. By solving this equation, I get it is alpha divided by n plus delta whole to the power 1 over 1 minus alpha. Fine. Now this is your steady state capital stock, golden rule level. This is the capital stock that's going to maximize your per capita consumption. This is your steady state capital stock. The steady state capital stock coincides with this golden rule level of capital stock if I simply set alpha equals to S. So if household, the savings, fraction of savings, that fraction of income that a household save in the solo model, if you have a per capita capital stock, this is the example. If S is equals to alpha, then KSSG is exactly equal to steady state level of capital stock. Then we actually obtain a steady state level of capital stock that is maximizing my per capita consumption automatically. If alpha is not equals to S, then there is a provision of changing my savings rate to maximize my consumption. So suppose if S is greater than alpha, what happened? My steady state capital stock is higher than my golden rule level of capital stock. In that case, what is the policy prescription of the government? You reduce your savings rate. If you reduce your savings rate, your steady state capital stock will gradually move towards the golden rule level of capital stock, and your long run consumption is going to increase. If alpha is less than S, the prescription of the government should be that why don't you increase your savings rate? If you increase your savings rate, your steady state capital stock will move towards the golden rule level of capital stock, and your long run consumption is going to increase. So the problem with the solo model, that is the permanent problem with the solo model that cannot be solved, is that this savings rate is exogenously chosen by the household. So the savings rate that household will choose, there is no guarantee that will be a savings rate that going to maximize the welfare. Here the government intervention is necessary, and from this particular problem is called the dynamic inefficiency problem of the solo model. And if I go over here now, if I go to, let's say, our solo model diagram that I was just explaining to you, now I think it is much more clear to you. So you see over here, suppose this KSA star, this is my steady state level of capital stock is belonging something in area, let's say in B, and what is happening, this is my golden rule level of capital stock, and your steady state level of capital stock is higher than the golden rule level of capital stock. It automatically means that actually you are saving higher. Your S is greater than alpha. What is the prescription? That you reduce your savings rate. If you reduce your savings rate, your steady state capital stock will gradually move closer to the golden rule level of capital stock, and you will move increasing your consumption. So here, if your savings rate is higher, that means your savings rate is higher than alpha when your production function is Cobb-Douglas. When savings rate is greater than alpha, you reduce your savings rate. If you reduce your savings rate, your long run per capita consumption is going to increase. Similarly, if your savings rate is less than alpha, that means you are not saving enough. What is the government policy should be? That you increase your savings rate. If you increase your savings rate, your steady state capital stock, which is initially less than kg, you will gradually move towards kg, and your long run consumption is going to increase. So the production function that we have taken with a simple example, the optimal savings rate, which is welfare maximizing savings rate, is alpha. If S is greater than alpha, you are over accumulated, reduce your savings rate. And if it is S is less than alpha, you are not actually saving enough, you increase your savings rate so that your welfare is maximized. This is basically the things. In the solo model, since the savings rate is exogenously chosen by the household, that how much fraction of my income I'm going to save, it is exogenously chosen. So there is no guarantee household going to choose S equals to alpha. Okay. Any question?
So, what factors will affect this condition of alpha is equal to S means the exogenously chosen alpha?
Your alpha is not exogenously chosen. your savings rate that you are choosing, there is no guarantee you are going to choose S equals to alpha. There is no guarantee you are going to choose a savings rate that is welfare maximizing. So whenever your savings rate is not exactly equal to SG, in my simple example, my SG is basically alpha. When your savings rate is not equal to SG, there is a provision that if you modify your savings rate, your per capita consumption in the long run can be increased. Two cases can happen when S is greater than SG. Suppose SG, which is basically my alpha in this simple example, your savings rate is greater than SG or savings rate is greater than alpha. What is happening? If you reduce your savings, your long run consumption will increase. Similarly, when S is less than alpha, you increase your savings, your long run consumption will increase. But there is absolutely no guarantee. It is possible that you have chosen S equals to SG, but it is a fluke. There is no guarantee that you are going to choose SG. Getting my point?
Yes, sir.
So suppose alpha, generally we take alpha equals to 0.3. But in the solo model, nobody guarantees that you are going to choose S equals to 0.3. If S is higher than 0.3, you are actually over accumulating capital stock. You reduce your capital stock, your per capita consumption will going to increase. If his S is less than 0.3, you are not saving enough. You increase your savings, your steady state capital stock will increase, and your welfare is going to increase. So what is the optimum savings rate? The optimum savings rate that is maximizing my steady state per capita capital stock, in this simple example, it is alpha. How do we calculate that? It is that capital stock where the marginal productivity of capital equals to n plus delta, which is actually we have shown graphically over here. So this graph actually shows that you see the kg where a prime k corresponding over here n plus delta, this is my kg, this is my steady state capital stock. That means in this simple graph I have an over accumulation of capital stock in the long run. In this case, the policy prescription is you reduce your savings rate so that your steady state capital stock becomes, and you choose a savings rate in such a way so that your steady state capital stock and the golden rule level of capital stock actually coincides. That means you choose a savings rate, you decrease a savings rate in such a way so that the savings schedule intersect n plus delta multiplied by k schedule at this point where I am highlighting. So you reduce your savings rate, bring the savings schedule down in such a way so that it intersect n plus delta multiplied by k schedule at this point. If that happens, then your steady state capital stock is exactly equals to golden rule level of capital stock. Whenever your savings rate is different, there is a provision to modify. Clear? Any question?
Sir, what harm will it do if alpha S is greater than alpha?
What harm does it do?
Yes, sir.
You tell me what harm it can do if S is greater than alpha.
Sir, consumption will be lower.
Your long run consumption is going to be lower. That is the harm. Your saving is ultimately you are consuming. That is your welfare. You have chosen a savings rate which is actually reducing your welfare, either through the over accumulation of capital stock or through the under accumulation of capital stock. If S is not properly chosen, there is a unique S where your welfare is maximized. If your S is not equals to that unique S, which is the golden rule level of savings, then there is a provision that you modify your savings rate so that your welfare is maximized. Right?
Yes, sir.
Okay, if you understood this properly, if I go to this figure now, there is something written over here. Where it is? is here. If you concentrate in this figure, it basically says this is basically your golden rule level of capital stock that is maximizing your consumption. In this figure, I'm measuring consumption in the y-axis, per capita capital stock in the x-axis. So there is a kg over here. This is the steady state level of capital stock that is maximizing your consumption. If your capital stock is higher, if your steady state capital stock is something in region B, that means if your steady state capital stock is higher than golden rule level of capital stock, it basically says if you reduce your capital stock by reducing savings, your long run consumption is going to increase. Your long run consumption is going to increase if you reduce your capital stock and reduce your savings. Can you tell me what happens to my short run consumption? This figure says that if I reduce my savings, my steady state capital stock will go down. It will gradually converge to KSSG and my long run consumption will be maximized. But in the process, when I'm reducing S and I'm reducing K, what is happening to my short run consumption? Is it going to increase or decrease? The figure says my long run consumption is going to increase. Suppose KSSG is basically, let's say 10, but my steady state capital stock I am getting 15. What is the policy prescription? You reduce your savings rate in such a way so that your steady state capital stock, which is 15 now, becomes 10. Why? Because when my steady state capital stock is 10, my long run consumption is maximized. So in this process, when I'm reducing my savings and gradually moving towards my golden rule level of capital stock, continuously my long run consumption is rising, and I will reach a maximum when KSS equals to KSSG. In this transition process, what is happening to my short run consumption? It is rising or falling?
Sir, from B to
From B to
kg.
from
Sir,
any point to the
we are decreasing.
savings is decreasing.
Yes, sir, and from the formula that we derived yesterday, we can. It is.
What is happening to my short run consumption?
Yes, sir. That is 1 minus S times Y.
No. That is 1 minus S time YT. Yeah, fine. CT equals to 1 minus S time YT.
And YT. So, okay, YT. There is no.
No, that is a unique answer. Just like my long run consumption is going to maximize at KSSG. So if I have a capital stock, something let's say higher than KSSG, I will continuously reduce that by reducing my savings rate and I'll reach here. In this process, my long run consumption is rising and it is maximizing. It is maximized over here. So in this process, what is happening? My short run consumption. If my savings falls, obviously my consumption rise. Continuously, I'm reducing my savings. When I'm reducing my savings, my short run consumption is going to rise. So when I'm moving towards higher to lower, from region A, any consumption higher than KSSG, and when I'm continuously reducing it, not only my long run consumption is rising, my short run consumption is also rising. But if my capital stock is something in the left hand side of KSSG, that means I am not saving enough. What is the policy prescription? You increase your savings rate. If you increase your savings rate, my graph says by increasing savings rate, I am increasing my per capita capital stock and I reach over here KSSG, my long run consumption is maximized. But in the process, I'm continuously increase my savings. My consumption is actually, my short run consumption is falling. So when you are actually moving from region A to KSSG, your long run consumption is going to rise, but your short run consumption is continuously falling. But when I am moving towards the right hand side to KSSG, both my short run and long run consumption is going to rise. Hence, if I am in region B, that means I am in the over accumulation of the capital stock. If my savings rate is higher than SG, it is called a dynamically inefficient region. Because if I move from region B to KSSG, both my long run and my short run consumption is going to rise. So if I am in B, obviously I am in an inefficient region. But when I'm in region A and then I'm moving towards KSSG, I know my long run consumption is going to rise, but my short run consumption is going to fall. So I cannot say that A is an inefficient region. No, but B is clearly an inefficient region. Because from region A, from any consumption to the higher of KSSG, if I move towards KSSG, both my short run and long run consumption is going to rise. But if I move from the left hand side of KSSG to KSSG, my long run consumption is going to rise. But in this process, since I'm continuously increasing my savings, my short run consumption is going to fall. So A is an inconclusive region, but B is clearly a dynamically inefficient region. Because if I move from B to any point from B to KSSG, is better for me both in the short run and in the long run. Okay, this is basically the problem of the solo model. The solo model can give you a capital stock which is not optimum in the long run, and there is a provision of improving it. People have realized that, and then other type of model where savings is optimally chosen, those kind of model has appeared in the growth model region, and that model is not, basically those models are not in the purview of this course, they're beyond the scope of this course, and we will not actually discuss that. But the important thing to note over here, you see, my long run growth of per capita output depends on G. Long run growth of physical output depends on population growth and technology growth. They're independent of S. So if I concentrate only the long run growth of my model, that problem with S does not appear at all. So if we concentrate on the long run growth of the model only, I can actually use solo model very easily, no problem, absolutely no problem, because my long run growth is independent of S. What S does, S has a level effect in the solo model, but S does not have a growth effect in the solo model. So when my S rises, my steady state capital stock rises, my steady state output level rises. So level of capital stock, level of output rises if my S rises. But if my S rises, growth in the long run is independent of S, because we have already seen my per capita output is growing at the rate of technology in the long run, and as a result my physical output, which is capital Y, is growing at the rate of population growth and technology plus technology growth in the long run. So long run growth can be easily analyzed in the solo model, because this problem of AS and dynamic inefficiency does not appear when we analyze only long run growth in the solo model. And that this is a very robust result. So you use other kind of model where your AC is always optimally chosen. You have a short run impact, but those model also gives me that result that per capita output in the long run is going to increase at the rate of technology in the long run, and physical output is going to grow at the rate of population growth plus technology growth in the long run, because they're independent of S. So if we concentrate only on the long run growth, I can use solo model easily, I have no problem. But if I also concerned about the short run fluctuation along with long run growth, solo is not a good model. Because this problem of dynamic inefficiency, that you cannot, there is no guarantee that the chosen ACE is optimal. That's the problem that remains with the solo model. It's exogenously chosen. Any question? So we have started with a very simple solo model. the problem that we have identified, that there is no per capita growth, but data says there is a per capita growth. How do we solve this problem? We introduce a technology over there. When you introduce technology, the long run growth of per capita output is determined by the technology growth, and it is matching with the data. But this problem, this dynamic inefficiency problem of solo model cannot be solved, because the very assumption of the solo model that household is saving a constant fraction of its income, whether that savings is the optimal saving that is maximizing my long run consumption or not, there is no guarantee. But so this problem remain unchanged. But if we concentrate only on the analysis of long run growth of output, capital stock and everything, they're independent of S, and solo model can be easily used. But if we concerned about both short run fluctuation and long run growth, then we need a model where savings rate is optimally chosen. Any question? Priyansha?
Yes, sir.
Is it clear?
Yes, sir.
Okay. No clarification, no question. Okay, then let us do one thing before analyzing this human capital more in detail. I am giving you a problem. Again, the first thing that you have to do, you have to give me this fundamental equation first. Same solo model where a constant fraction S of your entire income Y you are saving. So in per capita form, so per capita investment is standard. Small k dot this is my fundamental equation at the steady state, small kt dot plus n plus delta kt, that is my per capita investment. Till now, per capita investment equals to per capita savings. We have said that, okay, fine, I am actually saving a constant fraction of my total income. So this is basically we have till now as solo model f of kt. This is my fundamental equation till now. Now suppose I introduce a government over here. And what is the role of the government? Government is taxing your labor income and capital income at the rate tau. Okay, so if your labor income is WL, government is taking away tau multiplied by WL. So your disposable income is 1 minus tau into WL from your labor income. Similarly, from your capital income, ultimately you are earning R into KT. Government is taking away tau into R into KT. What is your disposable income remains 1 minus tau multiplied by R into KT. So government, you're taxing your labor income at the rate tau. Government is taxing your capital income at the rate tau. And you are saving a constant fraction of your disposable income. What should be the fundamental equation? So I'm introducing a government. In the solo model, what is the role of the government? Government is taxing your labor income and also your capital income at a constant rate tau. What you are doing after paying taxes, whatever remains to you as an income, your disposable income, you are saving S fraction of your total disposable income. How does my fundamental equation changes? This is my per capita investment in the left hand side. That should be equals to my per capita savings. So I have written a savings rate S. S should be multiplied with what?
1 minus
So
tau.
S, yes, sir.
Bolo bolo.
1 minus tau.
Okay, let me write it down. One minus tau. Then
F of kt.
f of kt. Is it f of kt, or I will write this, right? Wt
Yes, sir.
plus RT kt, right? So disposable income from the labor income in the per capita form is 1 minus tau multiplied by Wt. Disposable income from the capital income in terms of per capita, it is 1 minus tau RT kt. So you are saving a constant fraction S of your total disposable income. This is equals to this Wt plus RT kt, constant return to scale technology, zero profit, pi equals to f of kt minus w minus RT kt. When pi is equals to 0, w plus RT kt is basically f of kt. So ultimately that boils down to S 1 minus tau f of kt. Rest of the term is simple. So now if you solve this fundamental equation, your solution of KSS will be this. You see, what will be the solution of KSS? Suppose you have a Cobb-Douglas production function. Can anybody tell me? If my production function of Cobb-Douglas, and this is the fundamental
S,
equation.
S, S times 1 minus tau
Very good.
divided by
Bolo
n
bolo.
plus delta.
Whole to the power?
1 by 1 minus alpha.
Ah. So government has a role to play. Government can simply choose a tax rate that can affect your KSS. So if your steady state capital stock is higher than KG, government will simply raise the tax rate in such a way so that your steady state capital stock converges to KG and your per capita consumption maximized. Similarly, when your steady state capital stock is lower than KG, government simply going to reduce the tax rate tau in such a way your KSS become KG and your long run consumption is maximized. So that is the role of government in the solo model, to so that your saving. So now you see that your effective savings rate is basically S into 1 minus tau, right? This is the effective savings rate. That savings rate can be manipulated by the government by changing the tax rate. And why government should do that? Government should do that. Government will choose that because government cannot guarantee what particular ACE you are going to choose. Just like in this simple example, my KSS will be exactly equals to KSSG in this case when ACE into 1 by 1 minus tau ACE into 1 minus tau equals to alpha. right? So what is my tau? What government should choose as tau? Can anybody tell me? Tau equals to
1 minus alpha by s.
1 minus alpha by s.
very good. This is exactly what government going to do. Government will simply choose this tax rate. If we choose tax rate, this KSS will coincide with KSSG, and you achieve your maximum welfare. That is the role of the government over here. Okay. Because government really cannot guarantee that what AC you are going to do. This is basically your discretion. This AC is your discretion. But the effective savings rate, AC into 1 minus tau, tau can be chosen by the government. The tax rate can be chosen by the government. Government will choose this particular tax rate so that your KSS coincide with KSSG, and when you get your KSSG, your long run consumption will be maximized. So this guarantees your steady state consumption, steady state capital stock is exactly equals to golden rule level of capital stock, and your consumption is maximized. Another important thing to note over here, this fundamental equation. This is one example. One particular proposition is, if individual saves his entire capital income, then automatically the steady state capital stock will be the golden rule level of capital stock. When individual is saving his capital income, what is basically his saving? A prime insert equation new. So individual is savings his entire capital income, जो हम लोग कल कर रहे थे, a prime KT multiplied by KT. This is my fundamental equation. Right? Now you divide both sides by KT and you set K dot equals to 0, you automatically get this equation back. At the steady state, you will get this equation back. This is the fundamental equation. This is the savings, and this is your capital income in the per capita form. Individual is saving his entire capital income. So per capita investment equals to per capita savings. You divide both sides by KT and set K dot T by KT equals to 0. You get your steady state capital stock, which is A prime KSS equals to N plus delta. And this is basically the first order condition that gives me a golden rule level of capital stock, which is welfare maximizing. So when I solve this equation, this particular KSS will be automatically is this kg. Is this. So that means if you are an individual and by fluke you save not only a fraction of your entire income, you only save your capital income totally, then your steady state capital stock will be automatically with the golden rule level of capital stock. The steady state capital stock will going to maximize your welfare automatically, but there is no guarantee as an individual you're always going to save your entire capital income, and hence the role of government comes into picture, because the effective savings rate is basically AC into 1 minus tau, where the tau can be chosen by the government in such a way so that the KSS coincide with KSSG. In this simple example, the tau is basically 1 over alpha minus s. You get KSS equals to KSSG. Fine. Okay. Sneha,
Yes, sir.
is it clear?
Yes, sir.
Okay. Now, what does a government do? Government takes some fraction of your labor income, some fraction of your capital income. तो सब लेके गवर्नमेंट क्या कर रहा है इस मॉडल में? What does the government do in this model with those income? In this solo model, all other assumptions remain unchanged. I'm introducing a government. Government is collecting a fraction of your labor income, a fraction of your capital income, and that fraction is basically tau. What government is doing? So government, what is the government income? Tau into WL plus tau into RK, right? This is the amount of income government has. What government do with this income in this model? Your labor income is WL. Tau fraction of your labor income is taken by the government. So government income from your labor income is tau well. Similarly, your capital income is RK. Government has taken tau fraction of your capital income RK. So government income from your capital income is tau RK. So what is the total income of the government? Tau into WL plus RK. WL plus RK is basically Y. So tau multiplied by Y. This is government taken. Total income was Y. Government has taken tau into Y. Disposable income remains 1 minus tau into Y. That is basically you are saving, and that is generating investment. The question is, what does a government do with this extra income tau Y in this model?
Government expenditure.
Where is the government expenditure? I have not introduced government expenditure. My national income identity is Y plus Y equals to C plus I. That is why I equals to S. अगर गवर्नमेंट एक्सपेंडिचर मैं घुसाऊं, it will be I plus G equals to S. Then this entire fundamental equation will change. You see, this is my per capita investment. This is my per capita savings. That automatically says I am actually working with a national income identity Y equals to C plus I. Had it been a G, that there should be a small g, just like this. If there's a government expenditure, there should be a small g here, which is the per capita government expenditure. But I have not written that, so government is not spending. What the government is doing here? Faisal?
I don't know. I can figure it out.
तो गवर्नमेंट क्या कर रहा है भाई ये लेके?
Yes, fit
कौन
नहीं हो
बोलेगा?
रहा है क्या?
Invest,
हाँ
investing,
हाँ, बोलो बोलो बोलो.
investing.
कहाँ पे? Why, if
As
government is investing, that particular term should appear in the national income identity. क्या कर सकता है गवर्नमेंट? Moitri Das?
sir, I'm thinking.
हाँ?
Sir, I'm maybe not thinking.
I am not clear. तुम क्या बोल रहे हो सुनाई नहीं दे रहा. Anyway, कौन बोलेगा? Who's going to say this?
The subsidies that it gives to different.
There is no subsidy here. The model ends there. There is an individual, he is basically saving a constant fraction S of his disposable income, that is generating investment. Government is taking tau into Y. Perfectly competitive market structure, constant return to scale technology, सब कुछ हो रहा है. Where is the subsidy here? Sachi Jalote?
Sir, maybe the government is helping in the technological progress.
देखो ये जो मॉडल मैं अभी सॉल्व कर रहा हूँ,
Yes, sir.
यहाँ पे there is no technology. I have not introduced any technology, any technological growth over here.
So then, maybe in the production of.
Production depends on capital stock, production depends on labor. There is no government here.
Sir, when we took C plus I तो हमने government expenditure include नहीं किया उसमें.
नहीं.
हाँ तो सर like फिर taxation का point नहीं आ रहा समझ. क्या
हाँ
I'm
नहीं,
not.
तो हो क्या
हाँ
रहा है?
फिर like
Government is taking something from you, but I have not introduced any government expenditure here.
सर होना चाहिए क्योंकि वरना
Yes,
वो इक्वल नहीं
तभी
होंगे फिर तो.
equally
Sir,
equally
maybe
कैसे
reserves.
हाँ, but मैं लिखा क्यों नहीं? Is it my mistake? The government is taking that particular part and throwing to the ocean. That's the assumption, which is not clearly spoken over here. If there is a government expenditure, वो वहाँ पे आता. Your what is called your fundamental equation would have changed in this fashion. If there is a government expenditure, that government is spending, then this is G. And this is basically your this part. Okay, यहाँ पे G नहीं. Let me just do it over there. So this is basically the example. There is a plus G here. Right? But the non-productive government. Government has taken it and thrown to the ocean. And that particular part of your income is gone. You can assume that you have never produced that part. So you have not produced f of kt. What you have produced 1 minus tau f of kt. That is basically used in the economy. Rest of the part has gone. Better assume it is not there. So in this simple model, there is absolutely no other role of the government other than taking taxes. That is unrealistic, but the objective over here is just to show that government has a role to influence your effective savings. Even if there is government has no role, no other role, any kind of investment and other role has no role to the government, but still government has a role to influence your effective savings, and that can maximize your welfare. Forget about the other role of the government, no problem, but still government has a role in terms of influencing your savings rate. Okay, fine. So this is basically the solo model without human capital. We will discuss human capital part in 1 or 2 lectures later, but without human capital this is fine. So now we are actually able to answer all the question why countries are different in terms of their income. Per capita income is growing in terms of technology, labor share is 1 minus alpha in national income constant, capital share is alpha in national income which is constant. All the things can be matched. The thing is, again मैं तुम्हें बार बार बोल रहा हूँ, when you are analyzing long run growth of anything per capita is rate of growth of technology in this solo model. Long run growth of anything physical, capital Y, capital K, is N plus G, population growth per technology growth. No other parameter has any role to play in determining long run growth. N, delta, S, alpha, all those parameters, they have a level effect. When they changes, per capita capital stock changes, per capita output changes, per capita consumption changes, per capita savings changes. Level effect, rises or fall. But when they have no growth effect. Long run growth effect. Short run, they have a growth effect because the fundamental equation says that k dot by k equals to s f of k minus n plus delta. That is k dot by k is a growth. But the short run growth can be influenced by all the parameters. But the long run growth is only influenced by N and G. Clear? So इसको ठीक से याद रखना. A lot of people has this confusion when answering. So if I ask you a question, suppose um, the depreciation of the capital stock increases. What is the impact on your long run growth? Zero, no impact. But suppose there is a huge influx of migrant population to your country that increases your population growth rate. What is the impact on your growth rate? The impact is there is no impact on the per capita output growth because the per capita output growth in the long run depends on technological progress G. So there is no impact on my per capita output growth rate, but my physical output capital Y, the growth rate will increase because capital Y is growing at the rate N plus G in the long run. ठीक है, इसको याद रखना. When you are reading it, and read that part very carefully because a lot of people has this confusion. And this is actually saves the solo model. When people realize the solo model has this problem, the savings rate is not optimally chosen. You can choose a savings rate which is giving you a suboptimal outcome, which is giving you a dynamically inefficient outcome. By reducing savings rate, your long run consumption, short run consumption maybe both can increase. Even after realizing that, the solo model survives because if we want to concentrate only on the analysis of long run growth, the long run growth is independent of S. So we can continue with the solo model if we want to analyze long run growth. And actually we're going to do that. The other kind of model that we will study over here, we're going to introduce because we'll just concentrate on the long run growth behavior in those kind of model, and we will just concentrate on the solo model. No problem. Because the other area of the growth literature where people analyze both long run growth and also the short run fluctuation needs a different kind of model where the savings rate is optimally chosen by the individual through utility maximization. That is beyond the scope of this course. Another example I will give today, and then I will finish today's lecture. Suppose my per capita production function YT equals to f of kt which is equals to capital A of kt. Suppose this is your production function. My fundamental equation is this. You're saving a constant fraction of your total income. I am not changing that. Fine, no problem. Just like the solo model, this is your per capita investment and this is your per capita savings. Fine. If you divide both sides by KT, what ultimately you get is this. K dot T by KT, that is the rate of growth of per capita capital stock, equals to S into A minus N plus delta. There is no technology growth, nothing. Only the population is growing at the rate N. This. And suppose SA is greater than N plus delta. SA is greater than N plus delta. That means the rate of growth of per capita capital stock is always positive, even if there is no technological progress. So when the rate of growth of per capita capital stock is always positive, there is a perpetual growth in the per capita capital stock. There will be a perpetual growth in per capita output also without any technological progress. Possible. This is exactly the example that I have given in the last class. When we solved this solo model mathematically, we said when alpha equals to 1, you see, this is basically AK is the production function. It's basically a special case of the Cobb-Douglas when alpha equals to 1. When alpha equals to 1, we have said there is no steady state exist, and as a result, there is no point of converging to a steady state. What is the implication of that? That anything per capita, you see the first Caldor fact, the per capita output is growing, and it is not its rate of growth does not decrease. Till now, we have actually addressed that particular fact by introducing a technological growth rate. When I introduce a technological growth rate in the solo model, in the long run, it is growing at the rate of technology. But there is another way of handling it, and literature also have seen that if I have a AK kind of production function, a production function of Cobb-Douglas type with alpha equals to 1, I can still generate a continuous growth in per capita capital stock and per capita output without introducing technological growth rate. Possible. This actually generates another era of growth models. That how could I achieve this kind of stuff? We will discuss one or two model later where the Cobb-Douglas production function with certain modification becomes AK kind of production function. And whenever you have a AK kind of production function, you can generate perpetual growth rate of anything per capita without technological progress. Solo model में देखो alpha less than 1, per capita capital stock can grow only if there is a technological growth in the long run. Per capita output can grow in the long run only if there is a technological growth. The only thing I said, if alpha equals to 1 for some reason, and my production function becomes AK, in this case, even if we do not introduce any kind of technological progress, I can still generate continuous growth, perpetual growth of anything per capita that matches the Caldor fact 1. This generate another type of growth theory, and we will explain that. Okay, this is basically keep this particular stuff in mind, that if there's a AK kind of technology, I can have a perpetual growth rate in per capita capital stock. And since my per capita output depends on per capita capital stock, my per capita output will also grow perpetually, even if we do not have a technological progress. But when alpha is less than 1, we have to introduce a technological progress factor to generate long run growth in output and capital stock. Okay, hopefully this is fine, and we are ready for our first internal examination, which is due on 13th of September. I'm going to send you the link today of question. It will be a written question. You have to write it down. My TAs who is going to conduct those examination. They're going to share a particular folder with you in the Google Drive folder. Your answer, your typed answer, you have to just submit that in that folder, and that will be evaluated. Okay, so 13th of September from 3 o'clock to 5 o'clock, you're going to have your examination, first internal examination. And your 14th of September, there'll be a discussion of your exam. And then we'll again continue. We'll discuss some human capital after that, and then we'll go to other kind of growth models gradually. But we will stick to this fundamental equation. We'll stick to this solo, because in other kind of growth model, we'll only concentrate on long run growth. In solo, you see, we have discussed both long run growth and the short run transition towards steady state. But in other kind of growth model that we'll study, we'll follow solo structure. A constant fraction of savings is basically saved, and investment equals to savings. But we will only concentrate on long run growth. Why? Because I do not want to get involved with those kind of problem that my savings rate is not optimally chosen. My long run growth are independent of S, and we can easily use solo model to analyze long run growth for due to that reason. Okay, any question?
Sir, when we talked about tau, this was also something that was said by Solo itself.
That by said by?
Yes.
That is said by?
So your voice is breaking for me. Hello, sir.
No, you are properly audible. What is your question? फिर से बोलो.
Sir, when we discussed the intervention of the tax, that government will take tax so that we are able to get that golden rule thing. So that was something which must have also been a part of the solo model. Like this is a part of solo model, I think. So how was this accepted at that point of time? Because as you said that it's not something which is real, because the money that government takes, it all obviously has government expenditure. So like how was it, like I get the point that at other point of times the conclusions that we have discussed do satisfy what Solo has done, but I couldn't get that how this was accepted.
Not getting
Because
your question at all. I think you are missing the crux of the problem. I think you have not realized that why this particular tax example that I have introduced over here. The tax problem the tax example I have introduced over here just to show that government can influence your savings rate to take you to the golden rule level. Nothing else. And even if government has no role, no other role, no kind of expenditure, no kind of infrastructure building, nothing, a simple government who only collects tax and does not do anything can still influence your effective savings rate and take you to the golden rule level in the solo model. That's the objective.
oh, okay, sir.
सर सर एग्जाम सब्जेक्टिव है.
Subjective. You have to give answer. You have to
तो
solve
सर
numerical.
टाइप करना है या फिर रिटन स्कैन करके?
If you write properly and you scan it and you send it, fine for me. If you type it, fine for me, no problem. Only thing that it should be a soft copy and it should be legible.
ओके सर. तो सर हाँ कुछ रह गया सर, वो मतलब कुछ पैटर्न का भी कि कितने क्वेश्चंस या ऐसा कुछ?
There will be 2 questions, 20 marks. All the question have their part, A, B, C, D kind of part.
Okay, sir.
And there'll be questions on subjective, there'll be questions on where you have to solve something numerically. Fine. Anything else? Sarthak Brijwasi?
Yes, sir.
Fine, no problem, no question, no clarification.
Sir, I do have one question.
Bolo.
Sir, uh, is there any case we can find S A is less than n plus delta?
S is less than alpha and
S
delta.
S A is less than n plus delta.
Okay, if this is the case, what is the implication? There will be absolutely no growth. There's a negative growth rate. Your per capita capital stock will continuously shrink in, and your ultimately it will become zero. Your output production will become zero, and the economy will actually remain in the origin. When SA is greater than n plus delta, if the parametric setting is such that SA is greater than n plus delta, you can get perpetual growth in per capita capital stock and per capita output, even if you do not introduce any technological progress. But if it is less than that, you will come back to origin always. Your rate of growth is negative. And that's not
Yes, sir.
interesting,
Understood, sir.
right?
Yes, sir.
Hmm. Sagar Kumar Karn.
Yes, sir.
ठीक है? Any clarification? Any question?
No, sir.
No. Then it's fine. Then I'm going to end today's lecture over here. Please get prepared for your internal one. It will be on 13th from 3 o'clock to 5 o'clock. Please read my notes carefully. Please read that two books, relevant part of those two books, uh, uh, Jones and Walrath and Barrow and Salai Martin carefully. Uh, two questions is both the questions are numerical, but some part of those question has where you have to explain it with economic logic. Two question, 20 marks. Fine. Thank you. Thank you. Thank you. I'm ending the meeting today over here.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.